So there's really three very important data structures, like basic data structures in Python. Aside from, like you'll make ones out of these, or maybe, like make one for yourself. But there's okay. I wanna do it this way. So it's always nice. Oh, there's wait, look, helping me out already. There's a list. There's a tuple, and there's a dictionary. So what are these? Dictionary. Very simple. Like the list really is, like a list. So basically, like some random items in here, Z, and the list. This is already a list, and this is actually how you construct a list in Python. A tuple you construct with XYZ has very similar interfaces. The biggest difference is that you can't change the tuple. The tuple is immutable. You can't change it. You can't make it longer. You can't make it shorter. You can't change the values inside. It's what it is what it is. In the list, in the other hand, you can make it longer and whatnot. And we'll talk about how you do these kind of things, make it longer and whatnot. And the dictionary is pretty much what it is. Like when it says dictionary, there's like what happens is that this is how you construct dictionary in Python. You put a hash and you put like a key right here, key. You put a value, like an object right here. And when the good thing about the dictionary is that each object you store inside has a key, and the key is how you extract it out. Very similar to like how you like have the index, right? You put 0, you put the key in here instead, and it will get you the 0 out. So let's construct some to kind of clarify this case right here, these cases. So a list is 1, 2, 3, 4, 5. That's a list. A tuple is 1, 2, 3, 4, 5. That's a tuple. And dictionary is 1, like 1. I have to give a key. 1, 2, kind of tedious, but this is what we do to make it a little faster. 3. 3. So if you're very familiar, like this is, like it's like a hashing, like this is like a hash, you use a hash to retrieve the value. That's what it is. Hash map. That's what it is. Yeah, hash map is a very good term for dictionary. And I said before, lists can be changed. A tuple can't be changed. So what you can do for the list is that you can actually add to it. So we'll play with the list first. Like what would you have here? Like list, a list. The append is one of the things you can do. You put 6 at the end. You append at the end. So we'll print list in here. A list right here. And yeah, so it just appends, and like you can actually add a plus another list, because you're kind of like putting 2 lists together. Bam, like that. So it's 6 now. 7, 8, 9. We'll print the list at this current state. Let's see what happened. What happens? Oh wait, sorry. It returns a new list. So new list right here. That is actually what happens. So you have to kind of, you're not really making the old list longer. You're adding 2 lists together, but you have to make sure that you're getting that list now. You're assigning something. So you go right here, 7, 8, 9, and yeah, there's like a lot of these kind of things that you can do for lists, and you can change it. You can actually even do what we've done for strings, and we'll talk about how similar they are. They're very, very similar in terms of how you kind of like think about the data inside. So a list, you can actually get what's the first, the 0th one, you can turn to 1, right? It's very simple, very similar. Sorry, not simple, but it's very similar. So you can actually go do the same thing. So 1, so we're starting from 1, 1, 2, 3, 4. We're gonna get 2, 3, 4. So 1, 2, 3, and 4 is the one we're gonna ignore. So put it in there. List slicing is the same deal. Like it has the same interface as the one you have in the strings, which is very, very nice. And as you see, the plus right here works like a string. You add 2 strings together, it becomes another string, right? And what I'm trying to get at is that like they have very similar implementations because they're very similarly defined inside Python. And the tuple is kind of the same, although the tuple you can't change, right? A tuple equals, we'll just make it short, 1 to 3. But if you want to add like a tuple dot append to, it doesn't work. Like it doesn't work because there's no append. You can't append to it. If you add them together, what really happens is that actually I have to double check this because play that one. It makes a new one, but actually it makes a new one. Kind of like how this works. It makes a new one. So it kind of works, but you don't actually change the original tuple, right? You don't change this tuple here, like new tuple right here. So if we print the new tuple out, print new tuple. We actually didn't change the old tuple right here. We didn't change it because it's unchangeable. It's unchangeable. But yeah, so like you can't kind of like expand it, you can't contract it. A list, on the other hand, you can't do. You can do that. And I'm trying to go back to like the concept of like the strings. If you realize, actually, I just want to I just want to reiterate what you can do with tuples here is the same as what you can do with strings or with like lists. Is that you can even do this logic right here. Just gonna double check if people are not following. I'm not sure about the data frame. I'm not sure what you mean by that. But yeah, we'll get back to that. I'll ask you later. But so the tuple can also do this, this nice slicing. And the reason for that is because they're all represented very similarly in Python, and they'd have really have the same interfaces, because like like the string really is like it's almost like a list of chars, and 1, 2, 3. They're all the same, right? They're all like they're in the proper terming for this is they're iterables. They're all something that you iterate to, so they can share some function actually shared between them. And that's like the good thing about Python. Like certain things will work the way you think it work, especially if people have been really diligent in implementing them. So like someone's been diligent. Oh, lists look like tuples look like strings. Why don't we just share the same API to all of them so that we can like too much headache on like why is the interface to access strings different from a list, when really they're the same thing in terms of like how you represent them abstractly, right? Okay, so I'm going to talk about like this really special one called the dictionary. And the dictionary basically still has the same interface. You still use sorry, give me a second here. We use still the bracket notation to grab stuff out of it, but we use the keys instead. And the keys now is 1, right? And we put 2 in there and 2 and whatnot. And yeah, so like there's actually a lot of ways to kind of like convert them between each other, but we don't have to talk about it right now. But yeah, the dictionary really is just that. Like it's a hash map. You put in like the index, you get the thing you stored into out, and it's very flexible in that you can actually store other things in there. So we'll copy these 2 guys here, and let's go crazy right here. A list is a list, a tuple is a tuple, and yeah, and we can even add another dictionary in here, another dict, which is, you can actually reference yourself, but let's not do that today. A is a terrible contents of a dictionary in here, but B, and this is completely valid. Like dictionary is a very flexible data structure in that you can do this. Like it kind of prints out, oh, there's a tuple, there's a tuple in there, dictionary. Yeah, it's very good. It's it's kind of like a struct, struct in C, if you think about it. But yeah, it actually kind of is like it. But yeah. So like you could store a lot of things in there. But yeah, so these are for basics, the basics that we have. Whatever you can do, like there's a lot of like funny there's a lot of additional things that you can do with lists. I'm gonna go back in here. Just to kind of like add a little bit of things there. I kind of jumped over it in my notes. I have like a flow of notes, then I didn't follow it. So now we're kind of, this is happening to us because of my own fault. We can actually put other things in, like a pen, like there's an append for sure. I read it in there. And you can insert very specifically to an index. So we want to put at the start 0. We want to put a 0 right here. So put 0. And we're gonna put the value, so index and 0 objects. So we can print the list now. And let's see what happens. So there's another list with 0 inside. And as I said before, like the insert actually changes the list. You can't do these operations for tuples, just to kind of reiterate that. And like one thing I forgot about the strings before, and someone had pointed out very nicely in chat, thank you about that, is the length functionality. There's length right here. As I said, like tuples, lists, and strings, they share a lot of APIs. Length is one of those. So you press that. And actually, a lot of things actually share that API. You can just see 7, 1, 2, 3, 4, 5, 6, 7. There's 7. Perfect, right? But yeah, this length, a lot of like things share this API. So you can use that one. Okay, so we're talking about these like iterable types now and whatnot. And sorry, I'm gonna delete this, and we're gonna go to the next part here is loops. So I'm talking about iterables, and iterables is something you iterate to. So naturally, something you iterate to, you're gonna go through with loops, right? And there's two constructs for geez, what are you doing, Pete? Okay, here we go. There we go. Okay, there's really two main constructs for loops in Python. So I'll copy these. Like you'll find something interesting here in that like they're all similar in terms of string. Okay, they all answer to the same API. So there's a while loop, and what you do in the while loop is that while excuse me expression right here. So let's say some variable. The thing about while is that it's very manual, so you gotta do like a variable, right? A var equals none right here. So you're gonna go or 0, put 0 in here. A var is greater than 5 or greater than 4. Then we sorry, wait. Sorry. It'll only execute while this is true. It'll always execute when this is true. Okay, so avar is -4, less than 4. So avar is 0, initially 0 equals 4. Okay, that works. So we go in, we start the loop, right? And we want to like do something about this avar. So avar is a list. We just go avar in here. Actually, we want to like. We actually want to like start it there because 0. Oh, yeah, it's fine, 0. And we kind of like getting like that value right there, right? Then yeah, actually, wait, I'm not following my own instructions, so we'll print something in there. Sorry guys. I'm not following my own instructions, so I'm gonna go kind of
avar to index.
Actually, yeah, you're right, Carson. You're right. We'll use index. Okay, because like I'm not following my instructions, my notes for some reason. I don't know what's happening with myself here. Sorry, guys. So Carson's right. I'm actually using the avar that has an index, so we'll just name it as index, and we're gonna print whatever is on that index right here. And what we're gonna do is that we always have to update. Like how loops work. We have to make sure that there's like a thing that we change, or else like we're kind of index plus 1. We're kind of gonna go in a infinite loop, right? And I've actually done like something like index plus equals 1. This is actually just a shortcut to like index equals index plus 1, but I didn't discuss that a while ago, so I can't really use it now. I'll just put it here as a note. Then yeah, this actually is a basic while loop right here, and we'll just play it very quickly and kind of goes around. And if we actually don't add this one right here, it'll crash. So we wanna stop that. Oh geez, yes. I've definitely done bad to this here. So we're gonna refresh. Leave page, yes. So we've done bad to it. Don't do that. Unfortunately, oh she's
That's a
okay.
danger of infinite
Yeah,
loop. So
yeah.
never do that, please.
Yeah, never do that. Make sure. So the while loop is kind of dangerous in that it's manual in every sense of the word. Like this is the only thing that stops it. And you want to make sure that you have your like your updating operation, or else you just saw what happened. And while loops are dangerous in general. So like I suggest you don't use the while loops, especially if you just have like this iterable right here that you want to use. We can use for loops instead. A lot easier to use and a lot straightforward in syntax. So what you do is that what you're doing is for a name, or put name like a value, and I'm gonna go in my list. So a list. So what I'm doing here is that yeah, put pass right here. Pass is a special keyword to do nothing, like no op. No op. Don't do anything. So what I'm doing here is that from each of the value list, I'm gonna take one out, stick the name into and value. So it's gonna be assigned to and value, and you can use this value already in your block right here in here. So let's go print. Oh geez. Print and value, and these two are pretty much the same functionality. And as you can see here, I didn't have to start an index right here. I didn't have to have this truth operation right here, like this conditional right here that I need to make sure that it will terminate the block or loop. And I don't have to do this operation. I just have what it does really is like it just goes through the entire list. So if I play this, does the exact same thing, although we can't really say. I'm gonna print like a nice little yeah, right here. So right here, it's exact same thing. Amazingly, like they don't do too much of a lot of like errors and whatnot, right? So that's really it for loops. Like this is like the most basic loops. If you want to be super fancy, I'll teach you another way to loop, but we'll do that after one other part here. I'll talk about it after functions. So yeah, so we'll talk about functions now. So we'll talk about functions now. Like we always want to go make sure that we're here. Functions, okay. And what functions are in Python basically is a set of like a block of code that has its own scope. And what scope means is that it's its own pretty much universe, like its own context, its own variables that lives just inside of that code block. Then you have inputs to that function, and you use that as like a reserved name, and that's like I believe the exact word is like the actually, I forgot, like in the variable, something variable, but don't quote me on that. So example function. So we'll make a function right now. And to make a function, this is actually this is a function already. Like for the identity function is that there's a def. The def tells Python that the next value right here I'm gonna have is a function, like a name of a function. Then what we put in the parentheses are the inputs, but in this case, there's no inputs, so we don't put anything in there, and we're going to put the names there. And inside in there, the password is the block of code where you run, another set of Python codes. So let's make a more complicated example in that, like I'm going to put input A right here and input B right here, and I'm going to go. We want to return something. So amazingly, Python just says, return input A plus input B. So we've made like a very simple function right here. We have two values, two inputs, and then let's try it out. So I was just gonna print example, and what's really nice? Why don't we use the actually what? Yeah, let's use the input. So input A, input 1. Try to make it a different name. We're getting kind of confused in here now, and I'm gonna wrap it as an int because I don't want it to crash. In value for input A, then we'll copy and paste this. So input 2, value for input B, then we'll just print the value right there. An example, input 1 and input 2. So when you see me use it, the values of input 1 and input 2 will get sorry, I'm using my fingers, but you can't see it, unfortunately. You can see the input 1 right here. I use it as a argument to input 1, and the value of it is gonna get assigned to input A within this block right here. And the input A only lives, like the value of that input A only lives within this block. Outside of it, it doesn't actually care. So we'll play with that in a second here. So first so like 2 and 3, this is gonna be 5. So and I was saying the scoping is very, very important for functions, because like you can actually define some input A right here. Input A equals 5, input B equals 3. Then we'll take this example out. Then we'll go right here. This input A, input B, and like we could actually do something like this example, and we're gonna put like 1 and 2. So we're kind of like overriding input A, input B with 1 and 2, but still there's still input A, input B right here, right? So we're gonna go right here, input A and input B, the same naming, everything same naming, and it's gonna be okay because this input A and input B only lives within this block. It's encapsulated completely in here. So you play in here, and it's still this like input A, so it's 2 plus 1, right? And it still kind of maintains the value right there. I'm just gonna double check if people are getting confused right here. We don't actually have to return one value. It's very technical how Python does this return value. Thank you guys for answering questions, by the way, while I'm kind of talking, because I can't hear anybody. For functions, you don't actually have to return one value. You can return 2 values, and the way you do it is like this. So we'll make a new code block in here. Def example 2, input A, and input B. And this is gonna be like complete identity function. So I'm gonna return input A and input B. And this is actually quite a very specific Python thing. Because what you're gonna do is that, like some A, some B. This is how you kind of like return it. 1 and 2, and expect that some A is gonna be A, and some B is going to be like whatever you turn in the second argument. And this is actually called Tuple Unpacking. And why is it called that? Is because this return value right here is actually a tuple. So this is actually equivalent to like return input A, input B. Then we're kind of just like this tuple packing is like if you have the number of like here, the number of names here is equal to the length of the return value here is gonna kind of like nicely map it together. But you're not limited to one return value. Just like it's done within Python with its own tricks, which is nice. And someone's asking separated with comma. Can we return? Yeah, separated comma. Yes, exactly. That's exactly what I'm saying right here. But yeah.
So I want to extend this a little bit.
Yeah, for sure.
You can return multiple values, like not limited only 2, but you can return like a whole number of different things, and they're in the tuple size. I mean the type. So when you do this unpacking, you can do that directly. But the thing is, the best practice for objective-oriented design is that each function does a single thing. So it is best that you return a single value. So in the future, it's more scalable, and you can decompose your complex function into multiple functions, so you don't have to return multiple values. But yes, you could return multiple values from a single function.
Yeah.
And also, Peter, do you want to quickly talk about the dictionary? Because I see some
Oh yeah,
confusion
of
there.
course. Yeah, let's see. Let's go back in here.
Unless you want to cover it later, if you have that in your mind.
No, I don't have it. I think I've just finished the dictionary part. Let's see what questions people have for dictionaries. I was gonna go over the top. I'm gonna answer very quickly Lisa's question. You can stop an infinite loop. You have to press the stop value here very aggressively, but like it's definitely very hard when it's going as fast as you can. Yes, yeah, it really depends on like what environment you're in. And let's see what people have questions for dictionaries. Yeah, thank you, Daniel. Enumerate is a very good way to kind of combine them together. Very nice. Can you call a dictionary in for syntax increment? Yes, you can. You actually can. The weird thing about the dictionary is that when you iterate through it, like we can actually check. We could always just experiment. Okay. So when you iterate through a dictionary, you're actually iterating through the key in the dictionary. So I'll do this right now. So like this is technically we just return 1, 2, 3 right here because when you iterate through dictionary, it's technically it's definitely iterable, but yeah, like it's returning you a key. What you can do if you want to do some other thing is that you can go items, and you can actually this will actually return you key values. This is how you can. This is related to like tuple unpacking again, because the item returns you a list. This items right here will return you like something like this. Um, this is what it looks like. Key one that yeah 2 2. This is what it would look like if you do the items actually. Sorry, and it kind of like just does this value right here. So I'm gonna write the different ways to do this. So that people can reference this later in key and value right here. Let's put comma here. You can actually print like this. So as you can see, like 1, 2, yeah, 3 right here. So that's how you can iterate to the dictionary like this, and you can iterate this as well to go, like a dictionary. Oh geez, a dictionary and the key. So you can go like that. So they have the same output. Yeah, that works that way. If you're showing different things, cutting and pasting.
There's
Oh
also
yeah, you're
layers
right.
method that you can use.
Oh yeah, it's actually thanks to reminding me that for that one. So there's actually another one we go values of value. So what's happening in the values is that it makes a list of just the value part. So we can go print value right here. So I'm gonna do it right here is that ordinary iteration, values iteration, and values key and value iteration. And I should actually print something like this. Key val, just the val, and just the key right here. So you have lots of options, which is nice. I'll play it now. The screen is kind of too big. You can't fit everything, unfortunately. But yeah, you can. There's a lot of options for it. So the value ones you want to see, the key val ones, yeah. Unfortunately, this one we'll delete this one right here because kind of confusing. Okay. So if you do in dictionary key, yes, exactly. Key, yeah, yeah, exactly. It's not multiple value, the trans tuple behind the scene. Exactly. That's one of the things about Python. It uses a lot of these techniques within itself. Unfortunately, like like it's kind of it's good, but maybe some mystery magic is kind of like hidden behind it. But yeah, there's a lot of Python stuff is done through tuples and whatnot. Do you guys still have any questions about dictionaries before we move on a little bit more for some function examples? If not, it's cool. So there's one more thing I want to talk about the example like functions is that we put input argument here, but there's actually another thing called a oh yeah, you're welcome. There's another thing called like a keyword argument, and the keyword argument what it really does is that it gives a value to okay. I'll get back to this. I'll get back to your question, Vanya. But the very quick answer is that technically yes, because as I said before, dictionaries is just an object as much as everything is an object. An object has a reference to this within itself. In Python, the this is self. And the next lecture would actually clarify it a lot. Carson and Keegan will talk about it a lot more. But it gets complicated in this because like the dictionary is a very it's a basic data type, but also it also is under the paradigm that everything's an object. So it's actually from a class, and the class has a reference to itself. So it's quite funny. It's quite a funny concept to think about because like it really follows its creed. But okay, let's get back to the example. The example function right now, I'm going to talk about keyword arguments. Keyword arguments is a very easy way to do default values. So for input B, I'm going to put a default value of 1. I want to make it to like a successor function. So what I can do is that basically, So I could actually just go return input A and input B plus input B. And what happened now is that I can actually call this. Get out of here. Okay, there you go. I can actually call this function without the second value because I've already input a default. So I can just go 1, yes, all 1. Then like you can still do this because it's the second one in here. You can put 1 in here, or you can put 2 in here, so it's going to turn 2. But also, like amazingly, you can do this as well. You can actually specify it. So let's say you do something else like this. Input C equals 1, right? And you kind of end up being like input C is a multiplier, right? Sorry, I'm gonna not to copy paste. So input C is a multiplier. Behind the scenes, you can actually use it just like without the input C being changed, it's just a normal addition, right? So we can actually put like addition. Like this is just normal addition without like okay. So without the input B, it kind of seems like a successor function. Successor being that like if you put n, what's the next number to n, which is n plus 1. So with the input B inside, input B being 1, it's just a normal addition. Then if you put input C inside equals 3. Let's make something there 5. This is a multiplication now. So and the thing is like you don't have to define them. Like you kind of change the behavior of the function in multiple ways because you've just changed the defaults and whatnot, and like a lot of different like this is like a really weird way of doing it. Like I wouldn't like make a function that does 3 things depending on the input. That's kind of look crazy in my opinion, but you can do it. If you want to be crazy, you can do it. So let's check out the output in here so that always nice to see what's happening in here. And yeah, so we've definitely we actually have like b equals 1, so it's like this one is like we can make a 0 in here so that it actually does this properly. There's a tiny bug right there. If you saw the tiny bug, and I put 1 in here, unfortunately adds 1 in here, so it's going to be 6 instead of 5. But sorry about that, guys. But so I just want to kind of reiterate what keyword arguments are. They're basically just values that you can have defaults for. You don't have to explicitly define them. And you can have them together too. Like if you want to have like a very complicated function right here. So sorry, I'm gonna type it out so that you can follow through. So start 1, we're gonna add 2. So input B equals 2. Then go input C equals 3. So we're gonna add 1 plus 2 first, which is 3. Multiply by 3, it's gonna be 9. So the last value is gonna be 9. So we kind of, we can kind of like have nice defaults without, yeah, it's just basically nice defaults and like things that you don't have to worry about if they're always going to be like this, and you could customize it a little bit. So that's it for functions. And one final thing here, I told you we can do like a fancy loop, and like you can really do that through recursion. And like this is like as a side, you can use your function inside of your function to kind of like do more things. So let's just do this here. A list right here is 1 2 3 4 5, right? And we're gonna go make a for loop, and we're gonna go with a list, and we're gonna use like a default index, right? Index equals 0. We gotta start at 0. And what we have to do is that we're gonna print a list. Oh, I'm gonna make this input list. Sorry guys, I'm gonna put this input list so it's not confusing. Even though it works, it like it's not. Yeah. Then we're gonna call. We're gonna call the for loop. We actually don't have to call return. Like if you don't call return, it's okay. The return just returns something. If you don't return anything, it's gonna do none. So what I'm gonna do here is that I'm gonna do for loop again. Again, input list, and the index equals index plus 1, right? And I might make I might do a bug here in a second here, but yeah. So the important thing about this kind of way of recursing or like looping through something, an iterator, is that you'd have to make sure the base case is always set up, like or like how you're gonna terminate the loop. So if the length of is what's this, like, is equals index, he just return, because like at that point so this is like, what's the length? 1 2 3 4 5. There's nothing in the 5th index, right? Because the 5th index is going to be like like 0 1 2 3 4. This is a 4th index, so there's nothing in the 5th index, so it's going to crash. So we're going to return before then, right? So let's call this out, for loop and a list. Then just run it, and it just pretty much does what the list does if you have the print as the block. So yeah, this is just a different way to do it. You could call your function inside your function, just as how you would learn it in like your classes, computer science and whatnot. This is just one exotic way of doing the loop. And yeah, thank you, Daniel. Yeah, spread operator. Yes, exactly. Yeah, like I sorry guys, I didn't know that a lot of people here are good with JavaScript. I could have used like better analogies like that. But thank you, Daniel, or Daniel, yeah, for pointing these out. For pointing out. These are great. These are very good analogies. But yeah, this is an exhaustive way of doing the loop. I suggest don't do this unless you really have to, because Python will stop you at one point for getting too deep. But one last thing that I remember that I have to tell you guys is that there's one thing called a Lambda. And the Lambda, what it really does is that it lets you define a function in one line, and a function with no name right away. So I'll just go with x plus 1. The anatomy here is that Lambda tells you, I'm going to define a function. I'm not going to define the name. I'm just going to define the argument right away. So the argument is x, and after the colon is what we're going to do, the body, right? So you can actually do this to x, y, x plus y, but we'll just do, so that's like one example. This makes a function. This is equivalent to to def some func x y return x plus y y. Where what happened here is that it implicitly returns whatever this value is going to be, and you can only have one expression here. Very important. You can only have one thing that it can only can only be evaluated to one thing. You can't have like two lines in there or whatever. And like this lambda x plus 1 is functionally equivalent to this some func to x return x plus 1. They're functionally equivalent. The only difference is that if you realize here, there's a name, right? There's a name right here. So when you call this some func right here, some func, you call some func right away. So, and like this is how you kind of refer to that function. The lambda is that you have to assign it to a name. And this actually, if you I want to remind you again, Grandmaster Fun, remind you again, is that everything in Python is an object. Even functions are objects. And because they're objects, you can assign them to a variable. So right now, a nameless function, func, because we're the grandmasters of func here. And we can assign it, which is nice. It's like, so now we could actually call this right here, and they're functionally equivalent. We just kind of went a roundabout way up to defining it. So right here, so two, they're pretty much the same. But yeah, just to make the big difference between lambda and like a normal way of defining functions is that the more normal way of defining functions implicitly asks you, or explicitly asks you, not implicitly, explicitly asks you for the name when defining it. But the lambda lets you get away without naming the function. So you can actually assign it to whatever name you want, or you can even assign it as like some variable, or some input value. And just it's like to kind of like what do you call this? Hammer down the point that everything's an object in Python, which is one of the best things about Python, right? We're gonna use the function as an argument. So I have this here, a function runner, func runner. We're running some cool, good funky things in here. Func input. And what we're gonna do is that I'm gonna go func input, and I'm gonna run, and this is gonna run it. So that's really our function. So now I'm gonna define a lambda. So like some I'm bad at names, which is maybe a sign of like something. But we're gonna go. Unfortunately, there's like no input in here, so we're gonna try to put an input of 1 right here, right? So x plus 1, and what we're gonna do is we're gonna run the func runner, and we're gonna make the func runner, some func right here, and it's gonna run the function for us. So it's kind of actually, yeah. Although like this actually doesn't return anything because it just runs it. So what we can do is that we can actually print. We'll do this print right here, so that we know the func runs the func. So the func runner runs the func, because yeah, I'm gotta get confused with their own names now. But okay, we actually need some value in there. Okay, so we've done the same, like run right here. We're kind of like we're sending the function into the function runner, and the function runner runs the function. It's just kind of like, just think about it as being the same thing. They're all the same. So it's nice that way. Okay, finally. Okay, one of the most important things in here is that there's some bugs in there that what happened right here. I'll copy and paste the code above right here. Print x plus 1, right? And when you saw me like very quickly just ignoring the error, right? So play this one right here, because it goes type error, right? And we're changing topics, if you haven't realized. We're right here right now, errors with sessions. Just to kind of like reinforce where we are. So this happened to me a few times today. I'm playing out there, and the function halts, just halts and tells me some, the stack trace, trace back, all these kind of like, words right here that, maybe some people know very intimately. Some people have no absolute idea. This is just basically what it's saying is that what's wrong with your error. Right, what it's saying here is like I have a type error, and this is the functional state of the program when it happened. And when I'm running it, so this is the interpreter telling you I'm running the function in the third line, which is right here, which actually shows right here. Some func crashed because the lambda function I made is missing one value, because this lambda we're expecting 1x right here, right? And what's really happening here is that like this is what we call an exception. An exception is like a bad state that we didn't actually take into account. And you're going to come across this a lot. So this is actually a very important thing to kind of know into how to deal with this. Well, the first thing you have to deal with this really is that, handle that path. But in this case, it's like a function, like, what do you call this? It's like arity path, arity error. Like arity meaning the amount of arguments to a function. That's what arity means, if you come across it. But yeah, so like there's an arity incompatibility. Like some func expecting one argument, but you passed nothing. And like let's say like somewhere long far part in your code, like you just can't give an argument. So what we can do really in this case is that there's a construct called try that and try, then there's a block with it, then except. The try except has to be together. This is very similar to the try, what do you call this in JavaScript? Try something. I forgot. Sorry. Daniel, help you out here. Try catch. Yes, exactly. This is try catch. The good thing about try catch here in Python is you can define exactly what you're trying to catch. So in this case, we want to catch the type error. But if you take this out, it's completely legit. Like you can actually print here, I made a mistake, right? So I read in here and I made a mistake because, like what would really happen is that, I failed in func, except it's going to catch it, and whatever is in the except clause, it's going to run. So that's great. That's great. Yes, very true. And in JavaScript, I'm a full stack developer, so sometimes in JavaScript I would catch everything, and oh man, there's some proper headaches from catching everything. And this is actually the point I'm going to try to make. Exactly, Daniel. Exactly. This is exactly what I'm trying to make right here, is that when you try catch something, you have to make sure you know what you're catching. So I'm going to go right here, type error. I am only catching this type error, and I can actually make a very nice, very, very nice error here. You're missing your argument. Yes, don't catch the ball. Perfect. Exactly. Yeah, so right here, there's actually, I want to put your right here, but this is, yeah, you have to escape because I didn't talk about that, but that's how you deal with it. Yeah, so I'll just put it right here. But yeah, you have to be very explicit with what you catch, because like sometimes some errors will be like very different. Let's go over here. So we'll change this print to print, right? Okay, so print doesn't exist, right? I didn't define some function like print. So I go in here, actually type error. That's actually right, because if you run this is the same error. This is actually the same error, because this is type error. I'm doing the wrong call here, because it's the same error, unfortunately. Let's find something then a different error, like a value error. How do we do a value error, or like a? Okay, let's make a new example. This is probably better. So we have here, we made a function here, failing function, and we want to find this what we call this value 2 right here. And in this failing function, or value some number, actually, we're going to find some number, right? In the failing function, it has an internal list, which is equal to like 1, 2, 3, 4, 5. Then I'm gonna return the index of this. And I said it before, internal list, and we go index of the sum number, right? So the good thing about this is that if you run this with the value 1, it's okay. It'll return you 0. But if you put it with something it doesn't know, it returns value error, right? Yeah, so like we want to try to catch that value error. So 3, 4, 5, wait. Except a value error, then we can just go like, you don't have that number. Print, we don't have that number. We don't have that number. So now, like, it's a nice error. But let's say like you made a mistake right here. You put like indie right here, and it's a value error. Like that's a type error. So you go over here. Now I made a mistake, type error. Like list doesn't have attribute, so attribute error actually is attribute error. So it's different error, not type error, attribute error, which is nice. Like okay, we don't have to worry about that one. But if we actually do this, it just catches everything. So like we don't have that number, okay. Like, and you put like something that you know for sure, put 1 in there. We don't have that number. Like, what? Am I going crazy? Am I going crazy? So yeah, just to kind of like iterate how dangerous that is. Yeah. Okay, so people are okay. That's yeah, true. True. It's actually not a random label. That's actually very good observation. It's not random. There's actually some very, very specific ones that Python defines. There's a value error, there's a type error, there's a what do you call this?
Attribute error.
Attribute error. Yeah, there's a few. It's very specific. So when it comes up, you can just copy and paste it. And you could copy paste right away. But sometimes you can actually define this very specifically. So I'll show you something right here. So we have this function again. This one always complains, right? And what we're gonna do is that we're gonna raise an error, and this is how you actually raise the error inside. We just raise some value error, right? This is how you do it. But I'm just doing this as an example. But like you could actually define your own. But actually, you know what? I just realized that I'm overstepping now. We just reserve it for next time for Carson. Carson, make sure you guys do that, right? So now you can actually do this. Like the errors themselves, like if you're wondering how the errors are being called inside, it's actually just exactly like this. Like it just raised. The keyword is raised, and you put in the value, the error that you want. Then you can actually do this now. So this one always complains. This one always complains. You call it except value error, right? Then print. We're good. We good. So now it gets caught. But if you put something else in here, attribute error, doesn't get caught. Sorry, attribute error and whatnot. So this is like the basics of the attribute error, value error. Yeah, okay, yeah, exactly. Because we raised the value error, we stopped right there, and it didn't catch it. So we're not good. We're gonna complain. We're gonna complain for sure. And yeah, that's pretty much it for try except. There's actually a few ways to do this. Like you can actually, there's one more thing I can do. Like you could put this right here, like this, a comma, and say if we get attribute error, it get value error, catch it. That kind of deal. Or actually, how do we do this? You have to do this, I think. Give me a second, or maybe I'm living in the Python. Yeah, okay, there we go. Sorry about that. I missed the explicit tuple definition. But yeah, that's what we do. Like if we want to catch two different things. So let's say like sometimes you put attribute error in here this time around. It's still caught. It's still caught. Okay. So finally, we don't have a lot of time, unfortunately, but we can do a very, very simple to-do list with all these things that we've done, right? So what we can do right now is that, we can define, like, we'll make a list first, like our to-do list, right? And you know what? Let's make it into a list. This list for sure, because this list. And what we can do is that we can define a few functions to do add. So we add to list and item. Then we'll just pass for now, and then the remove from list item. Then finally, what am I supposed to do? When we go a list, the item list. Pass. And actually, if I've actually forgotten some things in there. We have to put the list in here. How can we insert something in item? So item list. We'll put item list in here too, just because we need them, right? So what should we do to add to the list? And that's pretty simple, actually. We just go item list dot append, right? And we go to item. Then how to remove the list? Let's double check our functionality. We have one called remove. Amazingly, we have one called remove, and we can do that. We'll just go item list dot remove and the item, and expect this to have some error. So we got to use some of that skills that we just learned. Then finally, for the last thing here, for item in item list, we're just gonna print out the item, right? Or the item, not the item list. If you want to do it per line, but also you can do it like in one go. But yeah, so that we have this nice. Let's do this now, because this is pretty awesome. Because like now we can just go. We'll do this crazy while loop right here, while true, and we're just gonna go. We're just gonna go infinitely add. So while true, input new task equals input thing I want to do. Then we're gonna call our add to list. Then we do a new task. Then we're just gonna, we're gonna call like, what am I supposed to do right away? Am I supposed to do? Then we're just gonna go our to-do list. But actually, if you see right here, like I just copy pasted that. Sorry about that, guys. Our to-do list. Yeah, there you go. So when I run this, it's just gonna fill up my list over and over, like sleep, study, work. Yeah. So that's a nice to-do list. Very, very simple. But we don't actually know how to delete, unfortunately. So we'll stop it for now. And it has a keyboard interrupt. But yeah. So what we can do is that, like, if the new task is to delete item, very specific word, what we can do is that we're going to ask for another to delete equals input. What should I remove? And then we go remove from list item to delete. Then our to-do list. Then we'll print out our thing again. Actually, we'll go else right here. There you go. Then we can just reuse this one right here. Okay, so we'll play this. Okay, or equals. Sorry, guys. Equals. I just assigned it, but really, what we need to do is a expression. So I want to sleep. I want to eat. I want to delete item. Okay. Or what should I remove? Let's go sleep. Eat. Okay, that's good. I want to remove wash. But the thing is, like, delete item. Then I want to remove what do I have here? Just make sure that edge case. Like go to school. To school. And we'll actually have an error. It's like, by error. Oh my geez. Remove not in list. So what we can do really is that, we can go try. Except, what's our error? Value error. Okay. Value error. Very nice. We'll load that one. and we'll just go. I'll just print print wait slash you're not doing that yet. Then that's it. We just pretty much took care of that one. So what you want to do, we want to eat, we want to sleep, we want to delete something, item, and we delete school, but it's not there. So you're not doing that yet, and eat, sleep. So that's really like I did this super fast, unfortunately, guys, because the time's almost done. I want to answer your questions, but you just made like a very very basic to-do list right here. That didn't actually use dictionaries in the end because I didn't have enough time. But I'm sorry about that, guys. But I will give you another example in this with the dictionary. But yes, I'll finish. I'll end this up right now. I was going to give you. I was going to reiterate that if you weren't able to follow very quickly or as with my pace, unfortunately, because I do talk fast and we're running out of time. This right here, I'm gonna give this to my colleagues, my team members right here. This sheet right here. I'm gonna give you another one, which has a cleaner, just completely documented version of this. You can just run through. So you're gonna have two different files that you can look at. And I'm gonna clean this up first, so that it's a little cleaner and whatnot. And there's not there, like I could put some more documentation in there. But yeah, that's really what I'm trying to say. Just like don't worry about it too much if you didn't follow. You're gonna get this anyways. And like I believe in you guys. Like you guys read through this, you're gonna be Python experts very soon. Yeah, so I'm open to questions at the moment. Although we don't have a lot of time. I know you guys probably are busy, but yeah, so I'm open with questions open for your questions. I'll be here for the next 10 minutes. And welcome everybody. Thank you for listening. Thank you for your patience. Maybe I make a lot of mistakes and a lot of people, and I want to thank my team members right here covering my back. Thanks, Daniel. Thanks, Carson. Thanks, Lee. I'm not so sure other people are here within the team. Thank you guys for covering my back and helping me with better analogies. And yeah, were you say Carson, or was it said something in the back here? Sorry, I didn't call you out.
Much appreciated. Yeah. It's a really nice effort.
Okay, so I'm gonna answer someone's question right here. How do you delete items if they're the same word but not the same syntax? Or same. You know what? They're not actually gonna get deleted. And showing you here is that let's read right now. So we go school and school. It's actually two different things. If you delete something, delete item, and you go school, you'll only delete school. Because they're actually two different things. What you can do in this case is that you can use another function. You can go item dot lower, so it's always lowercase, and you'll actually kind of realize that like if you do this right now, school, it's always gonna be school. But if you put school again, it's gonna append it, so it's there already. So we actually have to add another one here to kind of like take care of that case. So we're gonna double check in here. If item not in item list, and we can append. So now if we do this, so school, excuse me, school, and it's not gonna add it because it's already there. But yeah, that's in being in checks for membership. Membership. If you use this in a dictionary, it'll check the key, just letting you know. Let's see. Okay. Okay. All right. That's for you, Jen. Lisa here. String ABC. Still don't quite that C does. Like for the. Do you mean the like this? Something like this. A list is one. I'm just gonna make the list right here. 1, 2, 3, 4, 5, and like when we do this, right? List is like 0 to 2 or 0 to 4. Then there's the last value right here, right? The last value here is the step. So what you're doing here is that like, so we're starting at 4. The default value this is 1. So we're going to go up to the 4th index. So 0, 1, 2, 3, 4. So 5. But we're going to step 1 at a time like this. 1 here, then afterwards this one here, then afterwards this one to the 3, and then this one to 4. But if we put 2 in here, we're going to start with 1. Then we're going to go 2 steps. 1, 1, 2 to 3. 2 steps. 1, 2 to 4 to 5. So that's really what it does. It's kind of like tells you how big of a jump to the next value you're gonna take. So this one is gonna go 1 and 3 because it skipped the number 2 in here. So yeah, so like I guess like to kind of like make it clear, super clear in here that there's a picture. I should just use the picture right here, right? 2, 3, 4, 1, 1, 2, 3, 4, 5. So like we have like the thing right here, like A, B, then like let's say 2 right here. What I'm doing here is that if A equals 0, so we start 0 right here, and B is just the end. We go 1, 2. So the first one is 1, then 1, 2, so 3, then 1, 2, which is 5. That kind of deal. So it's just a step size. Okay, I'm gonna go up. My wisdom, you're not Pokemon trainer. Yes, yeah. I was pretty bad at Pokemon. I used a lot of rare candies. So don't be like me. Don't take the shortcut. Just curious, would it be possible to ask a copy of questions in ask and chat? Yeah, actually, not my call. I guess I can copy and paste it, but are we able to do that, Zinli or Parson? Copy
Yes,
the.
we'll do that.
Okay. All right. And yeah, you're welcome. You're welcome. I don't know how to say your name, Ying Tian. I don't know how to say your name. I'm sorry if I butchered it. But you're welcome. And everybody just said thank you. You're welcome. I just said that one specifically because I saw it right there.
Daniel
Okay.
is asking, Peter, is the art created in this class going to be sold?
Wait, oh my word. Well, yeah. If you want to buy it, I'll definitely sell it. I would go for an auction because I want to maximize that. I want to maximize it. But like there's bad pictures right here. I can make a screenshot, although it's
That's gonna buy
quite.
it for those cats.
Look at this, like this animal. You guys like this animal with no head. Okay, we gotta answer this Julie's question before we go on. If I have an error in this part, can you help me what I did wrong, please? Type error. Type
Someone
error.
answered that actually.
Okay, all right. Thank you. Okay, thank you to that person. Between list and arrays, what is more efficient data structure? In Python, list and arrays are basically the same thing, unless because like I think of an array as a linear data structure. Like is they're pretty much just like linear pieces in memory. So they're pretty much the same. If you think about tuple and arrays, wow, that's bad handwriting. Tuple and arrays, or lists, sorry. The optimization is very different in that like they still take the same space, but the way they kind of like, you know what, this is quite advanced topic for me to be honest, but the real gist of it is that like the tuple can't be changed. So the way they optimize this is that like they put it in like certain places that they can kind of like they don't have to worry about bridging to the next part, because like list has to be adjustable the size, so you have to make sure that there's enough memory size to kind of like cover the thing, right? At least give it like a like a different area. But the tuple is like very static sized. So I'm not answering that question right. I gotta have to research it for you because I can't really remember the big difference. But there is like a performance difference between the tuple and list. Very, very big difference. Yeah. Thank you, Daniel. This is definitely the Real Python is a great place to check out like good tutorials. They're relatively easy to digest, but also very thorough. I was talking about variables. I took like maybe 5 minutes, but if you check out the variables that they discuss, they're very thorough. They probably take you like 30 minutes to an hour to read through that documentation of just variables itself. But yeah, let's see. Yeah, perfect, Daniel. Thank you, Daniel. What resources do you recommend? Think as a computer scientist. Thinking as a computer scientist, the computer science itself is really about like it's the mathematics of algorithms and data structures and whatnot. Well, for one, you could probably take like one of these edX courses, like free courses on the internet, because it's kind of like mathematics, or it is mathematics. You have to think about it as abstract structures and and abstract structures and like relationships and whatnot. So it's same as learning a new math skill. So what really helps is like taking a course helps very, very much. Going to clubs. There's like Python Club, PyYYC, great club. Right, Carson, very good club to go to if you want to learn Python and learning like a little bit more. But yeah, just reading through books. I myself have like I have like like, I don't know what the Japanese term is where like you just collect books but really don't read them. I'm definitely one of those guys. I have one of these Art of Computer Programming. You can read that. Very dense, but if you read it, like I'll like to talk to you because you're probably a lot smarter than me. Because I can't read through that. It's very hard. And there's like a lot of like lots of the internet. I'll type what an SICP is very good. You just have to kind of work through it. I've gone through like a third of it. It's very fun, very mind blowing. Very, very good. I'm very sorry. I'm very sorry if I said something. Oh, sorry. Let's see. Let's see what other questions do you guys have. Is it something? What? Okay, that's Daniel. How to handle spelling errors? Handle spelling errors. Or usually like variable errors would be really on your IDE. I have a this one actually does like a terrible job. This actually does a very terrible job. PyCharm is very good. PyCharm is absolutely incredible in making sure you don't make mistakes. You're still gonna make mistakes, but PyCharm will help you a lot in discovering them at least. So I put like a little document there how to run PyCharm. This is very good. This is a lot better. Like this, this will help you out a lot, and it will highlight syntax highlight. It will set up everything for you. Yeah, just go through PyCharm. PyCharm will really help you out in there. Okay, let's see. Before you could, okay, yeah, true. Yeah, IDE for sure. Yeah, thanks, Carson. Automated Pro is 12, that's a very good book, especially if you're really starting to Python with Python, and you'll realize that Python has a lot of use cases and libraries that help you out in things the boring stuff. It's great. Is there an option to get PyCharm for free? Yes, there is. There is an option to get PyCharm for free, and you can use PyCharm Community. So if you go PyCharm to JetBrains in PyCharm, JetBrains, you go in here, download. You see right here? That's free, my friend. That's free. So you can use that one. If you input spare, like for spelling errors, PyCharm actually catches this for you. Like you can go in here. Let's go with my blender. Fahrenheit equals x5. See right here? It tells me green. Oh, show context errors. It's a typo. Oh, it's a typo. I see. Okay. Fahrenheit doesn't like actually it's somewhere in here, but yeah, it'll tell me it's a typo. Yeah. It's a typo. So yeah, it's definitely PyCharm definitely will save you there. I don't know if you guys can see, but yeah, that works out. PyCharm for free. Yeah, but yeah, for sure. Yeah, wait out for that one, Carson.
Okay, great, Daniel.
Yeah.
Just before we finish, I saw a lot of people just turn on their camera, and we're just gonna take a virtual photo for our class before we finish our class today. And great lecture today. It's really fun. It's way more fun compared to when I first learned Python. You guys are really lucky. So I'm just looking how, so you stopped the sharing. I'm just trying to,
I don't know how to stop
gallery.
it myself,
Okay, great.
unfortunately.
So
Yeah.
right now I have my gallery view, and I see, oh, we still have 60 people. That's great. And if you can turn on your camera, if you don't mind. Great. And if you turn on the gallery view, you can see you follow classmates. That's really cool.
I actually.
Great. So thank you guys. So I'm gonna just take a screenshot if that works. So I'm just gonna tell you. Yeah, great. Thank you, Daniel. So I'm gonna see 1, 2, 3, and I'm gonna take the screenshot when I count to 3. So are you guys ready? 1, 2, 3. Great. Thank you. Thank you so much. I think Daniel, sorry, Peter, please stay if you can. If the classmate, the participants has more questions, and if you don't have more questions, you're free to go, and have everyone has a great evening. And thank you so much, Peter, Daniel, Carson, and Daniel Ma for answering questions for today. We're gonna continue our communication and the chat in our snack. So, okay, have a great evening, everybody.
Yeah. I'll stay here for 5 more minutes if you guys have any questions. Yeah, thank you, everybody. Could you just weigh other respectable ways other than print to propagate errors back to the call stack? The print, like there's a few let's see, there's a few ways you can do it. There's PDB, which is the debugger, PDB debugger. PyCharm has their own debugger and whatnot. PyCharm has a debugger. But yeah, you're welcome. You're welcome. Cool.
That's good to know. I guess we call it a day.
Yeah. Thanks, everybody. Yeah, thanks, dudes.
Thank you. So if you folks have any questions, feel free to post it in the section, and we'll be there to answer questions. And I think that's a very successful first session. So thank you all for coming, and thank you, Peter, for this great course. I look forward to seeing you next time.
Great job. Great job.
Thank you. Thank you. All right.
Awesome. This is totally unrelated, folks, but I know that I know that I kind of said this in the chat, but if you do like these things, definitely go to meetups in your city. I know that Carson organizes the Pi YYC. I organize Edmonton Pi. I know that the Google Cloud in Edmonton and Calgary have just set up like a lot of really awesome meetups. So if you folks really like these, go to these meetups, and it's been pretty lucrative on finding work and finding like really awesome friends, like Carson. At least for me, we met through the meetup, and it's just something that I'd highly suggest going to take a look at. So yeah, just as an unrelated note, but great job, Peter. Sorry.
Thank you. Yeah, for sure. Yeah, go to your clubs, guys. Everyone wants people there. Also, when COVID is done, historically, PyYYC gives free food, so it's always good. So
Yeah, so you could turn pizza into code.
There you go. Yay! You feel for that.